It's already there. Smarter than I thought I was.
Here we go. So our English for this box is me or I, which is go. Second one box is you. Then our third person we have he, she, and our second way of saying you. This one is formal. This box also uses it. This is your big box. Then you have L, ADAP, and STED. The other one we have for us. Two ways of saying most over us, most over and most over us. Over here, we have our third way of saying you, right? All, and this is also informal. Also and also us. And yeah.
Oh, you got it. Yes, ma'am. Sorry, didn't know who was talking to me. What's up?
I have a question.
Yeah.
So I have an audition for a show on Thursday at my school, radio.
Mm-hmm.
I was wondering if I could practice it in front of everyone before we start class.
How long is it? Is it a monologue or
Yeah, it's monologue.
how long?
I haven't timed it, but I know it's under a minute.
Oh, sure.
Okay.
You're gonna say 3-minute monologue or something. I'd be like, no. But a quickie, a little quick one, sure.
Oh, I almost forgot to sign my name on my Rico.
Uh-oh, that's no good. Yes. This was.
I'm really nervous because I suddenly kind of got stage fright that when we were doing our audition work.
Oh,
And so I've been doing dance for literally forever,
yeah.
and I've been doing shows or like, recitals.
Yeah.
I've never ever gone stage fright. I don't.
Here, keep these in your layer because you're gonna need them to study, so you don't ever need to spin those and always hang on. There's a good morning, Eunice. How are you? Deal. Aw, sorry to hear that. That's no fun. I know COVID's going around again, so careful of that. It's no fun. Don't forget to turn in your homework if you have it over there.
I did it online.
Good. That's easier for me for sure.
My Rico might not match my week.
Oh, that's
Because,
okay. I know you used the other one.
Your Rico.
Yeah, you had extra Ricos to practice with.
For some reason that it was, I cannot find my homework, but I did it online.
Yeah. That's
The
fine.
teacher's book is gone.
I know. I can't tell you how excited I am. It was the weirdest thing. I got on to start grading. After everybody left, and I counted, I was like going through papers and stuff. And then I get on to start grading, and the first thing I see is the handed in logo under James's assignment in my other class. And I was like, how did he hand that in? So like I immediately click on it and I see that he's answered it. So I email him and I was like, it let you turn it in? When did that happen? He's like, it just let me turn it in. So Drew's upstairs. I'm like, so he's like, and like right around then I started getting emails from other people. I love it. I mean,
You like my hair?
it's very cute.
Last week when I was doing when I was doing the teacher's assignments,
Mhm.
I was like, my brother's like, bro, there's no use, bro, it won't work. And I was like, bro, let's just give it a shot.
It was,
I do the same thing, honestly. I did the same thing.
it was
I
so
just
exciting.
sending the assignments. And
It makes it much easier for me because it will auto grade, like multiple choice and stuff. Anytime you guys get something wrong, I'm gonna look at it, even if it's on Teacheries. If there's a question that's not right, I always look. But if all the questions are right, it just goes ahead and gives you credit, which is what I'm gonna do anyway. So it saves a ton of time. Plus, it's faster. Like you get your grade immediately. You can look online and see it. You don't have to wait for me to hand stuff back in. Okay, Starcy and Lewis, and I think they're coming. Maybe they're just a bit late. All right.
Well, yeah, they started work on the road outside your neighborhood, which
I know.
was really annoying.
That's why I warned everybody about it in the grill and chill. It's gonna be like that probably all year, because you know how it takes them forever to do anything, right? But they are actually going to knock down the front entrance of my neighborhood and build a new entrance. I haven't even seen the plans. I don't know what it's gonna look like, but whatever.
How are people gonna get in and out?
I don't know. It's gonna be lots of fun. Yee. There is a back entrance. I think you guys always come through the front because you're coming from Suwannee, but so there's the front with the gate and you go past the pool and the pond with the fountain. Does everybody come that way? You come in the other way in the back?
Yeah, I come from the back.
Yeah, he comes in because he's coming.
I turn a left when I'm in.
Yeah. You come down the long windy road with the trees.
Oh, yeah.
Yeah, there's almost always deer in the middle of the road.
Stop.
I hit a bat on that road like 2 weeks ago.
Wow.
And I felt I love bats. I think they're adorable. And this bat was, right at dusk, they do this thing where they dive because they're catching the mosquitoes and things, right? That's what they eat. Love bats, they eat mosquitoes. And this bat dove right in front of my van and boom, and it hit my windshield. And I was like, oh my gosh. And Drew was with me. He's like, Mom, you hit the bat. I'm like, I'm going back. So I turn around somebody's driveway. I go back and then I'm looking in the road. I'm like, is it here? Because if it was like hurt. I was gonna scoop it up and try and get it to a rescue or something, but I didn't find it. So I don't know if I sent it flying into somebody's yard or maybe it just was stunned and kept going, but I felt bad. All right, Emma has an audition coming up, so she just wanted to take a quick second and practice in front of us. Just because it's quick and it's under a minute. And I said, sure.
I was wondering if
So you're not off book yet, or you want me to watch?
Can you read to see if you know like
Make sure you don't miss any.
uh-huh.
Does it have to be exact or close?
Close.
Okay, good. Like an adjective could change or something like
Yeah.
that.
Or if like I skipped a part and then
Got
redid
it. Okay. Good show. Mm-hmm.
Okay. And when we're doing auditions, we introduce yourself even though
Yes.
we know it, so I'll introduce. Hi, I'm Emma. I'll be doing Violet Beauregard from Charlie and the Chocolate Factory in her interview scene.
Mhm.
I'm a gum chewer, but when I heard about these golden ticket things of Mr. Wonka's, I laid off the gum and switched to candy bars in hope of striking luck. In the hope of striking it lucky. But now, of course, I'm back on gum. I adore gum. I don't know what I would do without it. I chew it all day, except for a few minutes at mealtime when I take it out and stick it behind my ear. Tell you the honest truth, I wouldn't feel comfortable if I didn't have that little wedge of gum to chew on every minute of the day.
I really wouldn't. It may.
It might interest you to know that this piece of gum I'm chewing on right now, I've been working over for 3 months solid. As a record, it is.
That's impressive.
It's beaten.
It beat the record of my best friend, Miss Coraline Pennell. And for you two that just entered, I was practicing.
Cornelia Prinz medal. Here you go.
I can never
That's a good one. Good job.
practicing my audition.
Do you know a trick?
Thursday.
Can we tell you a good trick? If nobody's, you probably already been told this trick, but memorize the last line, then add the line before it. Work backwards instead of forwards.
Okay.
That really helps. That helps with music and with.
So you know what's gonna happen.
I'm
next.
sorry
Yeah.
we're late.
You're fine. All right, so we're gonna roll for today.
Yeah, I won.
I think everybody knows now, hooray, hooray, that Teacher Ease is functional, and I cannot tell you how excited I am about that. It's like the best thing ever. All right, so let's go with today's lesson. This is our last lesson of Unit 2, and then you guys have a Unit 2 test, right? This will be your first test that's not. Wow. No, don't,
I'm
there's
kidding.
glass.
Don't.
Okay, at least you don't
Okay.
back off.
Right, I'll get, I dropped my phone.
We were late because there was this guy with a stop sign
Oh
thing.
yeah, it's really.
And we left a little bit late and we were like, yes, we're gonna be right on time. We got stuck for 7 minutes.
I would say go ahead and help me grab them, but there was glass with that, so let me sweep it
Maybe
all.
next time invest in a plastic container.
Yeah, that's probably smarter. Can you lift the back, please? I'm gonna get underneath. Just look at it, went everywhere. The glass went like, it exploded.
It's great that it didn't go in anyone's eyes.
Yes, this is true, because nobody was wearing goggles, because we're not in lab, so.
Or I mean,
Look at it this way. At least the first glass broken in this
Okay, go ahead, you
year
go back.
was not done by a student.
Yep. Leave it to me, right? So I'm just gonna sweep it into a pile and grab the coins that look safe to grab, and then we'll go ahead and do our lesson, and I'll get it really cleaned up during lab, because I don't want to waste your class time cleaning up.
it was shattered into little pieces.
Yeah.
I got glass stuck in my heel while trying to clean up my mess.
That's terrible, isn't it? I've done that more than once, and it is not fun.
You gotta make sure Ozzy doesn't step on any. That would be very.
Yeah, that's why I said I'm gonna get it all straightened out during lab before I let him out. Okay, let me grab a couple of these. So you guys have your Unit 2 test coming up. Your study topics, I'll show them at the end of the slideshow, but they're also in your resource folder. So if you go to your resource folder, you can find them there. And you want to do that. Just like before, there's not going to be questions on the test that I don't list as something you should review. Okay? I don't throw surprises at you, except There are occasionally questions that go back to those first lessons on like scientific method and whatever.
Okay,
Those will occasionally pop up again because those need to always be there.
anybody but Lewis who guesses my birthday can have this.
What have you got? Oh, candy. Anybody but
April.
Lewis?
Mm-mm.
Who guesses my birthday?
No, very close.
July.
Yes. What day?
July
Mm-mm.
7th. Yes.
Yep, because that's Cole's birthday.
Mostly because he was the emotion.
Yep, I hate him, but you know, we can't have everything. Can't be
Yeah,
siblings.
you're the seventh, you and Cole, and then a lady from church, her daughter's birthday is also the
Do
7th.
you not like party?
What?
You don't like party?
No, I do. But I don't need any more candy.
I don't need any, that's why.
Okay.
Look at the maturity.
Candy today.
I'll give you my Skittles because I do not like Skittles. I absolutely love Skittles. No, I don't like Skittles, but I love Smarties.
Okay. That's enough time for that. All right, sorry, gang. Hopefully this is enough clues to get us through. All right, so last lesson before we get to our unit test. So we are doing the universe and the solar system and all of that. So we have different models of the solar system. What do you call the ones that have Earth at the center? Darcy?
The PTOLEMIC.
Ptolemaic is a good word for it. There's another word too. If there's Earth at the middle, do you know? Geocentric, yes. Okay. So who was Ptolemy? Do you see it in your notes?
Yeah.
Who is Ptolemy? What's it say about him?
It says here that
Mm-hmm.
he was a. Oh wait, no, it's not.
Ptolemy is the guy whose name starts with a P.
Oh,
Yeah, it's a weird name. Mm-hmm. So he had.
Egyptian mathematician, astronomer,
Mhm.
geographer, astrologer
Physician.
who lived in Roman Empire
Mm-hmm.
around 100 to 170 AD, well known for producing the most commonly accepted model of its time.
Right. So his model was not geocentric because it didn't have. I mean, it was geocentric because it had Earth at the center. What do we call the one that we know is right with the sun at the center? Okay, Emma. Mm, Starts with an H. You see it? Nico, do you see it?
Yeah.
What is it? Heliocentric. Okay, good job. All right, good job, everybody. So heliocentric. Okay, so helio is a root for sun. I'm pretty sure that's a Greek one, actually. So you've got a heliocentric model, and that is where you've got the sun at the center, and then you've got a geocentric model, and that is also a Ptolemaic. You can also call it a Ptolemaic model, which puts Earth at the center. So way back when we didn't know sun was at the center of the solar system, we thought the Earth was the center of all things, right? So how did we figure out the Earth was round? Earth goes around the sun. Sorry.
I know.
Here we go.
Because, the moon revolves around the Earth and the sun doesn't.
Here you go. All right, so let's see.
I used to love these.
Every single thing on this planet, we're all zooming through space right now, orbiting the sun at an average speed of 107,000 kilometers an hour. And we're rotating while we're doing it. But the sun, moon, planets, and stars all look like they're moving through the sky, right? So it's easy to imagine that we're staying put while they all move around us. As long as you don't look too close, which is why the whole idea that the Earth orbits the sun wasn't really accepted until a few hundred years ago, and it took a lot of convincing. A lot of the old geocentric model, where Earth's at the center of everything, was based on ideas developed by ancient Greek philosophers Aristotle and Ptolemy. They explained that the Earth stayed put at the center of everything, and anything we can see in the sky, the sun, the moon, stars, planets, everything, orbited it in perfect circles. But that didn't explain why planets, which at the time referred to anything that looked different from the background stars, including the sun and the moon, sometimes changed brightness, or occasionally looked like they were moving in a completely different direction. So the geocentric model tried to explain them using epicycles. These are imaginary points that were moving in imaginary circles with planets orbiting around those points. And it sort of worked, though eventually they had to draw more circles around the circles to explain some things and have the planets move faster or slower at certain points in their orbit. Diagrams of the sky were kind of a mess. There were at least a couple of Greek philosophers who disagreed, and the geocentric model was questioned by Muslim scholars since at least the 10th century. But for a long time, especially among Western civilizations, it was just accepted. Everything revolved around the Earth, even if it was hard to explain sometimes. At least until Copernicus came along. Nicolaus Copernicus was a well-known Renaissance thinker who spent the last few decades of his life developing a heliocentric model, where the sun is the center of the universe, which he published just before he died. And okay, we know that the sun isn't the center of the universe, but it was a lot closer to the truth. Copernicus realized that the math was a little simpler if you just had Mercury, Venus, Earth, Mars, Jupiter, and Saturn, the only planets we knew about at the time, orbiting the sun, with the moon orbiting the Earth. He used epicycles too, but all the planets in his model kept the same speed throughout their orbits, which is what you'd expect if the orbit is a circle. But it was still hard to prove that the heliocentric model was more accurate. For one thing, even if they made things simpler, those circular orbits in Copernicus's universe were wrong. And it was just as bad as the geocentric model for predicting how the planets would move. Then in the early 1600s, Johannes Kepler realized that orbits didn't have to be circles. And if he assumed that they were ellipses, the math fit the motion of the planets, sun, and moon a lot better using the heliocentric model. Around the same time, Galileo Galilei's telescope made things even more convincing, mostly thanks to Jupiter and Venus. When Galileo pointed his telescope at Jupiter, he was able to see its 4 biggest moons: Ganymede, Callisto, Io, and Europa. They were pretty concrete proof that not everything in the sky was orbiting Earth. Then he noticed something weird about Venus. It goes through phases, just like our moon does, from new to full and back, but it's much bigger when it's new than when it's full. That made no sense in the geocentric model, which predicted that sometimes Venus would be closer to Earth when it was new, but sometimes it would be closer when it was full. In the heliocentric model, though, the sun, Venus, and Earth lined up so that Venus would be closer to Earth when it was new. Even with all this evidence, it took a long time for the heliocentric model to be accepted. The church banned heliocentric works until 1758. These days we know that the heliocentric model wasn't exactly right either. The sun isn't at the center of the universe. There's a lot more out there. And if you want to get technical about it, both Earth and the sun orbit the same point, the center of mass of the solar system, which is just the center point of all the objects in it, based on their mass and how far they are from each other. Since the sun has 99.87% of all the mass in the solar system, the center of mass is pretty close to the center of the sun, but it does move around a bit, depending on where the planets are in their orbit. So one thing we know with 100% certainty is that the geocentric model is wrong. We've sent telescopes, probes, and people up there, but we've seen it for ourselves. Thanks for watching this episode of Sideshow Space, which was brought to you by our patrons on Patreon. If you want to help us keep making episodes,
There you go.
Yeah, we don't.
So Galileo is an interesting fellow. So Galileo was a man of faith, as many of these great thinkers were at the time, and he had a hard time reconciling church teachings with what his science was telling him. And he was basically trying to say, you know, they don't have to be exclusive of one another. Like he was saying that, you know, putting the sun at the center isn't necessarily it doesn't go against what the Bible is trying to say, even though the church said, no, yes, it does. And there was a big history. Yeah, there's a big history of Galileo being, quote unquote, excommunicated from the Catholic Church at the time. They later came back and were like, oops, he was right. But if you like to read interesting things, there's a series of letters written back and forth between Galileo and his daughter, who was a Catholic nun. And it's called Galileo's Daughter. And it's just letters between the two of them. And it's I've had snippets of it. I haven't read the whole thing. My husband read the whole thing. Apparently it's very, very interesting. So there you go. So solar system. All righty. By the way, did anybody see the Starlink train go by night before last? So Starlink, did you see it? Yeah, so Starlink are a set of satellites. Elon Musk is putting them up. And the idea is to get internet over the entire planet. So they keep sending up entire bunch. There'll be like a launch and enter a whole bunch of satellites. And they come out in a line. So they're reflective. So if you're down on Earth and you know when they're coming by, you can look up in the night sky and it's weird. It's like a line of perfectly spaced little glowing dots. They appear to be glowing because they're reflective. And they move in this straight line. It's really kind of crazy looking. My husband got a very good picture with the long exposure, but anyway, it's cool. And if you follow, there's a couple different apps you can get actually that'll help you know when it's coming. All right, so components of the solar system. Solar system consists of sun, planets, their moons, a variety of smaller objects that mostly revolve in the same plane around the sun. So what do you use to measure distance of an object from the sun, Eunice? Astronomical unit, good, or AU. We'll call it AU sometimes. So there you go. Modern technology includes complex telescopes, piloted spacecraft, space probes, and has allowed scientists to explore the solar system. So what were our missions called when we traveled to the moon? You know? You know what?
Space, right?
It was during the space race, yeah, but what was the mission? Do you know, Darcy? So it's Apollo missions are the ones that, yeah, Apollo, all of the Apollo missions, the goal was to get to the moon. So there were a bunch of them. It did, but we were racing against, who were we racing against?
Russia.
Do you know, Nico?
Soviet Union.
Yeah, Soviet Union, technically, because Russia was at the time the Soviet Union.
Now Soviet Union.
And what does anybody know about the political climate between the US and the Soviets? Do you know, Darcy?
It was like really bad. Like we hated each other.
Yeah, it was interesting. The two big powers were the US and the USSR, Soviet Union, Union of Soviet Socialist Republics. And they were communist, and the US was very anti-communist. And basically, there was what was called the Cold War. Your parents probably grew up in the Cold War. I did too. But there was basically just a threat of mass destruction over everybody's head all the time.
Lived in the UK, so but
Yeah.
have you seen that new movie Tetris?
No, is it good?
Oh, it is so good.
Cool.
It's about like the origins of Tetris and it like shows it in Russia. It's so good.
Oh. So recent space missions, we have near Earth missions, and then we have this unpiloted vehicle that carries instruments and transmits information. What do we call those? Do we know? So that's a probe. There's a bunch of those up there too. And then ISS is the International Space Station. And we just had a re-entry yesterday or the day before of some astronauts and cosmonauts. Cosmonauts are Russian. We're friends now.
Yeah.
Enough to be in space together. The ISS, the International Space Station, has a team of researchers from many different countries. It's not just the US up there. It's the US and Russia and China, and I want to say India, maybe some other European countries. It's really interesting, but they're all up there working together, and we don't currently have a shuttle anymore, right? So we used to use the shuttle to get our astronauts to and from ISS. So to get them home, they had to come home with like some other countries in their vehicles. Basically, they did the whole water splashdown landing because we were the only ones who had a shuttle that could land like an airplane. Like, I don't know if you've ever seen a space shuttle landing, but when the shuttle came in, it leveled off like an airplane and then it came down a runway. And we were the only ones that did that. Everybody else did splashdown capsules, which is what we did initially. And now we're back to that. That's what we're using again with some of the newer Artemis missions and stuff.
Why? Why are we changing?
Well, the shuttle program was retired in 2009, maybe 2010. Forever retired. Right, it was retired. It was very expensive to keep it going, and we found that maybe we should try some other methods. So
stock market crash of 2008.
No, actually, it had been planned for way before that. Plus, there had been some terrible shuttle disasters, which I'm sure you guys have heard of. Like Challenger is the worst one. Columbia was also equally bad. Challenger is one of those events where if your parents are in their mid 40s to low 50s, or even after that, you can probably ask them, where were you when the Space Shuttle Challenger exploded? And they can tell you exactly.
45, and my dad's like 50.
Yeah, your dad would probably, know for sure. I know it was
I'm only 40.
so I was at when I was a kid in public school, there was another school I went to 1 day a week. It was the way they did their tag program. So I went 1 day a week for their gifted program. And I was there at that school. And I was in like, I think 4th grade, but the 6th graders were watching the shuttle launch live because one of them knew one of the astronauts, which was not uncommon growing up in Virginia Beach, because a lot of those guys went through the Naval Academy and then became Navy pilots and then became astronauts after that. So there were, you know, Virginia Beach is a huge Navy town. My father-in-law went to the Naval Academy with Charlie Bolden, who was the head of NASA for a decade or close to a decade. So yeah, it's not uncommon. So what you got real quick?
Went to a school for like gifted.
Yeah, 1 day a week. It was cool.
That's cool.
We got to leave our, what they called our home school, obviously not homeschool, and go 1 day a week. It was great. All right, so phases of the moon. Okay, Lewis, what's this one? The different shapes or phases of the moon that are visible from Earth. Okay, yeah. So these are caused by changes in the relative positions of the moon, sun, and Earth. So these are all of your different phases. So this is what the moon looks like from Earth at different points.
I thought waning was that way and waxing was that
Waxing
way.
is, so it doesn't really matter which direction. Waxing is when it is going from full, it's when it's going from a new moon, which is no moon, to full. So it's filling, it's waxing. It looks like it's kind of emptying out, it's waning. So waxing is like getting more full and waning is getting less full.
Yes.
Mhm.
And tides are all like the waves are all
Yeah. So the lack of atmosphere allows the moon's surface temperature to vary. So what do we call the flat, low plains? Oh my goodness. Okay. All right, Carlos. The flat, low plains. He's looking. Help him out, Nico.
Maria?
See, that's a tricky one. Yeah, it looks just like Maria, but it's pronounced Maria, but it does look exactly like Maria. And this is another root right here. MAR often means sea, like marine, right? And these look like seas from Earth. Okay, so what do we call the mountains? All right, Lewis. Yeah, highlands. Okay, so these are the highlands. And then Eunice, what are the round depressions? Craters. That's great. And then, all right, Emma, what do the rocks, what do you call the rocks that travel through space? Yeah, asteroids or meteoroids. Okay, so meteoroid's a tricky one because what's going on there is you've got, okay, the meteoroid is the rock moving through space. Okay, the meteorite is the rock when it hits the ground. The meteor is the phenomenon of the rock moving through space, producing that tail of light. Anybody ever seen Shooting Star? Yep, very cool.
Oh, I wish I'm lucky.
So eclipses. What's okay? So obviously this first one is eclipse, right? So a solar eclipse is when what casts a shadow on what? All right, Emma. Solar eclipse.
The moon casts a shadow on Earth.
Close when the moon casts. Yeah, sorry, when the moon casts it on Earth. Yeah, that's your solar eclipse. All right, your moon's casting a shadow on a portion of Earth's surface. All right, what's the dark shadow cast in an eclipse? Eunice. The dark shadow that's cast in an eclipse. What's that? It's called an umbra. Is the shadow? We call it an umbra. It's a fancy word for a shadow. And then the less dark areas surrounding the umbra, Lewis. Do you know? Oh no, Darcy, thought your hand was up.
No, oh sorry. I know the next two.
It's this is the penumbra. Okay, and then a lunar eclipse occurs when, Darcy, yeah.
Okay, it occurs when the Earth casts a shadow on the moon.
Okay, very good. Yes. All right, now, who saw the total solar eclipse? What was it, like 8 or 9 years ago?
Oh my, I was
See it?
Wait, no,
Oh, were you? Okay. Well, we went up to Toccoa and we saw it. Does anybody know when the next one is? It's April of this year, this coming year. Yeah.
When I was
Guys, hang on. Uh-huh.
Smoky at the Wilderness, I think I don't know what it's called.
Yeah.
What it's called?
Mm-hmm.
You know, the water park, indoor water park.
Great Wolf Lodge or something. Yeah.
Yeah,
Okay.
I was there and there was a fire thing and we got to see a lunar eclipse
Oh, wow.
followed by a supermoon.
Oh, wow.
It was a big red moon.
Oh, those are cool. We got to keep moving. I'm watching our time now. Okay. All right, so I will say this next one's coming up in, I think it's April 9 or somewhere around there. And it's not going to come through here. It's going to come kind of through the center of the country from like Mexico, yeah, through Texas, Illinois, Ohio. It's going to go past the Great Lakes into Canada. And you know what? Like one of the best spots in totality, is at Baylor, where my kid is. So he's going to be able to go outside and get total solar. That's so cool. I'm jealous. Okay, so tides are caused by the moon. I'm going to come back to this one because I'm watching our time. But basically, the thing to know about tides is when the moon is closer to Earth, the gravity from the moon pulls the water out, and you tend to get higher tides where the moon is and lower tides when it's further away from the moon. All right, so terrestrial planets, these are the ones that are on this side of the asteroid belt, and these are the ones that are similar to Earth. There are 4 inner planets. So they're Mercury, Venus, Earth, and Mars. These are our terrestrial. We call them terrestrial, terra, meaning ground or Earth, because they're similar to Earth, okay? So Mercury, we're going to take a guess here. I'm going to let one person at a time guess. So this is our distance from the sun, okay? And this is done in kilometers instead of AU, so you're going to see how ridiculous some of this gets. This is Mercury. That's its radius, so from the center out. This is its temperature range, and this is how many Earth days one Mercury day is. So how many Earth days do you think a Mercury year is? Eunice, you guess this one. What do you think?
About 1,000 days.
1,000 days, he says. Okay, this one's 87.97. All right, so here's the next one, Darcy. You're going to guess this one. So here's Venus.
I don't know.
Here's our distance, and here's our radius, our temperature. So how many Earth days do you think a Venus day is? Take a guess.
This is gonna take a minute.
Make it quick. I'm watching our time.
Not a clue.
Not a clue. All right, so it's going to be 243 Earth days for one. So that means Venus is rotating much more slowly.
So a day is longer than a year.
Almost, yeah, 365 days in an Earth year. So yep. Okay, so here's Earth. What's our radius, Lewis? You want to guess?
On this, I think
Mm-hmm.
it said minus 290 degrees Fahrenheit instead of
That's-
290 degrees.
Yeah, because it has no atmosphere. So it's okay. So it's what's this one? What's our radius? Do you know? You want to guess?
2,800.
2,800, 6,371 from here to the center of the Earth,
Did you
kilometers.
know that if you stacked up the US's debt to all the countries in pennies, it'd reach to Pluto?
That's pretty frightening. All right, next up, all right, Nico, Mars, here we go. So how many moons does Mars have? He's gonna guess. Take a guess, any guess.
2.
It's got 2, all right, but that was Nico guess. All right, so now we're on you, Carlos.
I'll
So-
give you
You'll get the next planet when we get there. All right, so we did those. That was our inner, we got our asteroids. There you go. We have a big belt of those, right? Mercury, Venus, Earth, Mars, asteroid belt. Then we move on. So then we have our gas giants. These are our outer planets. We call them gas giants. They're composed mostly of, I'll give you this one, the helium and hydrogen. So is the sun, right? So the 4 gas giants have small, dense cores of metal and rock, but they're mostly liquid hydrogen and helium. So we have Jupiter, Saturn's rings that you can see from Earth, Uranus, and Neptune. And Pluto, we used to call Pluto a planet, but now we call it a dwarf planet. Yeah, we changed our mind, and people have gone back and forth on this one quite a bit.
There's a sad video that it's a song that is
Oh yeah. And then we got comets. You can think of comets as dirty snowballs flying through space. Pretty gross. All right, so Jupiter. So this one's yours, Carlos. Do you want to guess the temperature on Jupiter? Do you think it's going to be colder or warmer than here?
It doesn't make colder.
Okay, so it is negative 108 degrees Celsius. So that is pretty darn cold. All right, so how about Saturn, Emma? Do you want to guess how far?
So kilometers, 500,000 kilometers.
All righty, how about that? 1,424,600,000. That's long.
That's all the way.
So Uranus, back to you, Yusuf. How many moons does Uranus have? Do you know? You want to guess? Yeah. 6 moons.
23.
27 moons. That's a ton of moons, right? All right, Darcy, Neptune. How many Earth hours is a day of Neptune?
Okay, holy crap. I want to say 42.97.
So it's rotating much more quickly, right? So now we have this whole chunk of the solar system, and then we have the outer. So this is the edge of our solar system, and this word here, does anybody know how to say it? It's Kuiper. Kuiper belt. So these are the objects in the Kuiper belt, and this is like it's like this bit of junk that's outside of the last planets, and it's just kind of spinning around. Yeah, it's called an Oort cloud. It's a sparse circle of comets, and they go flying around, and it's a mess. So there's our Kuiper belt, and this is where you will find Pluto, but you'll also find some other little dwarf planet. Eris is another one that's similar to Pluto that's been kind of tossed around in the same conversation, same categorization at times. So origin of the solar system. So we have something called nebular theory. Nebular theory states that the solar system formed from a rotating cloud of what? Emma?
Dust and gas.
Dust and gas is right. Okay. Anybody ever done the thing where you sit in a chair and somebody spins the chair and then you tuck in? Anybody ever done that?
Or I've done that.
And you spin faster?
I did that with my friends. I did it in the back as a little kid, but like
Yeah.
held up the chair.
That's kind of how we think the solar system condensed, is that same process.
I did on the part.
Okay. Yeah.
I'm gonna
So our composition and size of the planet. So our terrestrial planets are relatively small and rocky, right? That's our Mercury, Venus, Earth, Mars. And then our gas giants are large. They have low densities because the outer solar system was cool enough for ice forming compounds to condense. So when it comes to getting energy from the sun, so what is this? How is the sun producing energy? What's the process, Lewis?
Nuclear fusion.
Yes, nuclear fusion.
the actual
Nuclear fusion. Did you?
He was like
Nuclear
very
fusion.
dedicated.
So this is,
I thought
here's
that
a word.
was, like,
Hang on, listen. Here's a word that I'll disown you if you get it wrong.
Oh.
So a nucleus is the center of something. A nucleus is the center of an atom. It's also the center of a molecule. Nucleus or nuclei is plural. So the word is nuclear, not nuclear. Lots of people have said nuclear, including former presidents. I wanted to strangle George Bush because he did it consistently. So nuclear, always remember nuclear. So the sun remains stable because the inward pull of gravity is pulling it all in. So basically you've got hydrogen and helium, which are the first two elements on our periodic table. They're very light elements, and they're so light that when you put a lot of gravity in and pull them together, they can smush together and fuse. So two hydrogens become a helium, and that's what happens. And then that helium will eventually split, and that releases energy, and it keeps going on and on and on. That's fission.
How many presidents have you lived through?
1, 2, 3, 4, 5, 6, 7, 8, 9, I think.
I've lived through 3: Barack Obama, Donald Trump, and Joe
Oh, I
Biden.
forgot him. So yeah, 10. All right, so we got to stay, or 11. Yeah. So we got to stay here tight with our lesson, watching our time. All right. So the sun has a core, a radiation zone, and a convection zone. So the sun's atmosphere, it has 3 layers: a photosphere, chromosphere, and a corona. This picture right here, you can see the corona of the sun, this very outside bit, when you get your full eclipse like this. So if you're able to go in April, we got some really great pictures from when we went, because my husband actually went over to somebody's telescope and put his phone down into his telescope and took a picture, thinking it wouldn't turn out great, and it was amazing. So really cool. So features of the sun's atmosphere include sunspots, prominences, solar flares. Like I said, we'll come back to the videos later because make sure we have time. Distance to the stars. So what is the distance light travels in a vacuum in a year? Anybody know what that is? Eunice? Not clusters. It's our light year, like Buzz, light year. That's how long it takes light to travel 1 year in a vacuum. Space is a vacuum, right? So, well, mostly. And then we have parallax. Parallax is the apparent change in position of an object with respect to the distance background. So I have a video on parallax that I have for you guys. You can watch. It kind of explains it. I don't expect you to fully understand it at this level, but it's cool to know what it is. So we'll come back. Properties of stars. So astronomers classify stars by color, size, brightness, color, and temperature. Which color is hotter and which color is cooler?
Oh.
Do you know, Carlos?
Blue.
Blue is hotter, and what's cooler? Do you know?
Red.
Red, right? Okay, very good.
The opposite. Of
So-
what the Earth has been
Well, if you
telling
look at a flame, a regular flame, like fire in a fire pit or a candle,
it's always like
the
really
bluer,
blue.
yeah, the bluer and clear part at the bottom are way hotter than the orange and red. So, uh-huh,
Or like if you
Okay.
have a fast stove when you're turning
Yep.
on, it's mostly blue.
it's
and
blue. Yep,
Sometimes it's a little red. But it's
that's
blue.
right.
I've seen
So
it
the how a star appears from Earth is what? It's its apparent brightness, and how bright it really is its absolute brightness. Da-da-da-da. All right, so we have this thing called a HR diagram or Hertzsprung-Russell diagram, and this is basically just shows it puts the stars on a spectrum, and it kind of groups them together by brightness and size, and it can tell you kind of,
white dwarf.
yeah, all those things, yeah.
Yeah. I know.
So how do stars form? So you have your nebula, which is your big cloud of gas and dust. And then you have what's called a protostar, and that's when the nebula starts heating up. And then it contracts, spins and contracts. And then you have an adult star, okay? And then that star's mass, after a while, it'll get unstable. Like it's pulling in on itself, right? There's gravity and it's pulling in, it's pulling in, it's pulling in. And eventually you get star death. So you get a white dwarf, then a neutron star, then a black hole. This will happen to all stars. So will our sun disappear one day?
Yeah.
Absolutely. We aren't anywhere near it yet based on what data we can tell from other stars. But there is a big star. There is a big star that is easily seen from Earth that is getting closer and closer to supernova, and it's Betelgeuse. Sometimes people say it's Betelgeuse. They say it Betelgeuse. But anyway, I've heard it pronounced Betelgeuse, Betelgeuse, Betelgeuse. But anyway, it's gonna, Betelgeuse, I think is correct. But anyway, it's gonna go at some point, and it might go within your lifetime. Scientists have been really watching it. It's getting closer and closer.
Well, will it go in your life?
Maybe it might. It honestly, it could go next month. They really don't know, but they know that it's closer than others around it. So galaxies, I'm just going to breeze through these because I'm watching our time. So galaxies are groups of stars and star systems, and we're in a galaxy. Of course, what's our galaxy called? Milky Way, right? All right. And if you're in a place where it's really, really dark and there's no light pollution, you can actually see the Milky Way. It's pretty cool. You can,
What?
yeah, you can see it streaking through the sky. It's really neat. So we have different shapes for our galaxies. So we've got spiral, we've got barred spiral, elliptical, irregular. Milky Way is a barred spiral. That's what we're in. And then we have quasars, which are these enormously bright centers of distant young galaxies. And then Hubble's law helps us with that. So this is on your test. So let's be sure we understand this. So astronomers theorize the universe came into being at a single moment called the what?
Big Bang.
Yeah. Okay. Big Bang. So they call this the Big Bang theory. Okay. And it's a theory. Remember the difference between theories and laws. What's a law? Everybody, what's a law?
It's like a definition.
He tells what
It's a
happens
fact. It's what happens, a fact. And then what's a theory? Why it happens, an explanation. Very good. Okay. So this is a theory. A lot of people will disagree with this theory, but this is a theory. So basically, it says that the universe expanded very quickly, then slowed down, and it continues to expand. We do have evidence to show that the universe is continuing to expand, which leads us to believe that it started from one point and is moving out. So this adds evidence to the Big Bang theory that there was one point and then it moved outward. We can use Hubble's law, and so we're thinking the universe is about 13.7 billion years old, which is really hard to comprehend, billion. But Hubble's law uses changes in wavelengths of light, which occur based on distance, and it has to do with the whole whether a star is becoming more blue, more red, and you can tell if it's moving away. And we'll talk later on this year about Doppler effect, which is basically Hubble's law with sound, or it can be light as well. But with Hubble's law, we can tell it is still expanding. It is moving away from a center. Yes.
So if our sun is like yellow and red,
Mhm.
does that mean if it became blue that we might be incinerated because
Yeah.
we're so hot?
That would be terrible, right? I don't know.
Or
So,
where he snapped and everyone disintegrated, where Thanos snapped and half the
Mhm.
people disintegrated.
That's right.
That's what all of us.
so dark matter. Okay, dark matter is matter that doesn't give off radiation and it cannot be seen directly, but its presence can be detected by observing its gravitational effects. And I have a really interesting video on this is some astrophysics stuff, and it's on particle theory and dark matter that we aren't going to have time for today, but it's linked. It's in your resources, right? If you go to resources, all those are there. If you want to watch something really funky, this one explains what dark matter is. This one shows it like an actual graphic of it. And this one talks about what would happen if you were to become dark matter, which is pretty fascinating, actually. It's really kind of weird, funky, moving into the realm of astrophysics. I hope you like math kind of people. So these are your Unit 2 test study topics. So understanding hypotheses. What is a hypothesis? It's an idea that can be
Tested and
Tested.
repeatable.
and repeatable, and it can either be what?
Proven or disproven?
Yeah, supported or not supported, right? Or the other way around, and it has to be repeatable. So Earth's composition and layers. Remember, we've got our what's the top layer? A
Man? No.
crust, which and then we have our lithosphere. Yeah, the mantle is divided into a lithosphere, a mesosphere, asthenosphere, and then we have our core, right?
But I have all these in my notes.
Plate tectonics and continental drift. Okay, so our continents are moving. What was it? What was the last big continent, supercontinent called? Do you know, Lewis?
Oh,
Pangea. You got it. Yeah, Pangea was the last big supercontinent. There have been others. Okay, Gowanda and a bunch of others, but Pangea was the last big one. And then what's causing the continents to drift? Do you remember, Eunice?
continental drift.
Yeah, what's causing them to move? Do we know? Do you remember? Oh, Emma.
Tectonic plates.
Tectonic plates are the plates that are moving, but what's causing the motion? Do you remember? Do you know, Lewis?
Magnetic.
That's how we know it happened. There's proof of that on the ocean, on the seafloor. So remember, it's the convection heat within the mantle of the molten rock rising when it's warmer and then sinking back down. And that's basically like a conveyor belt underneath that's moving the plates around. So we have two big solar systems. We have a geocentric and a heliocentric. The geocentric has what at the center?
Oh,
Geo, Earth, and then the heliocentric has what, Eunice?
the sun.
The sun. Great. Okay. And then what are the planets in our solar system in order? All right, Carlos.
Mercury, Venus. Wait.
Yes, you're right.
Venus, Mars, Jupiter, Saturn, Uranus, Neptune.
Yeah. Was it a song in your head?
Yeah.
I was gonna say I heard a little melody pop out. All right, and then our Big Bang Theory. I will suggest that if you don't watch any of the other videos, you do watch the one on Big Bang Theory.
So we get to watch the Big Bang? No, Big
yeah,
Bang Theory?
Because I want to be sure that you've seen it. You just watch it before you take your test. Be sure you really understand it. So these are the topics to study for your test, and then you'll be good to go. The test will open at noon today, and it'll be accessible until 8 a.m. next Tuesday. At 8 a.m. next Tuesday, it will stop. You will not be able to open it. You will not be able to answer anything. Once you open the test, you have 1 hour to complete it. It will not take you an hour, but you have 1 hour to complete it. If you walk away and don't come back, it's going to close it and you're not going to be able to get it open again. So if something weird like that happens, let me know, but be prepared, study these things beforehand, move all your study stuff aside, sit down, open it up, and just read through them, and it should be pretty easy. You guys should be good to go because we've been over and over it, so it should be good to go. Darcy, you have a question real quick?
No.
Last.
Wait, I was going to say, why does the show The Big Bang Theory literally have nothing?
Good question. I have no idea.
I'll take it up with the producers.
Yep. All right.